Good morning, everybody. This is Mr. Walker here, coming to you with our notes for today about triangle theorems. We got a couple ones that we're going to be hitting today, so make sure that you're following along. If you don't know what your sheet should look like, let me go through and show you it right here. Looks like this. Triangle theorems at the top. We got 1, 2, 3, and 4 theorems here that we're going to cover, and we're going to do the we do it, and I'm going to leave you guys to handle the I do it and the bottom. All right, let's go through and hit this. All right, so triangle theorems. First off, we got when given 3 side lengths, sometimes the side lengths will form a triangle, sometimes they won't. It may look like one, but we have to be able to verify that using our first theorem here. So we got this angle here showing up. I want you to imagine that we need, let's say, 2 other angles that we're going to make up with straws here. This is a little bendy straw. So if I go through and I make it up with another length here, and if I try to connect this, will this make a triangle? So imagine that this here would have to represent this last side here. Obviously, if you look at it, it's not going to go all the way from one corner to the other corner. Why wouldn't it? Because it's too short. Now, if we had another set of angles, let's say we got this straw here, and I wanted to connect it with another one. Would this one end up making a triangle here? Would it connect from here to here? If I drag it down, yep, it would. Now, when we do this, we want to make sure that our sides are going to end up connecting to make our triangles. So, take a notice of what we see up here. See, this one ended up connecting from this corner to this. This one, however, wasn't long enough to connect our 2 corners of our triangles. So, how is this going to work into our theorems? Let's go through and talk about the triangle inequality theorem. So the triangle inequality theorem says the sum of the lengths of any 2 sides of a triangle must be greater than the length of the 3rd side. So essentially, if you add any 2 sides together on a triangle, they have to be greater than the side that you didn't add. It has to always work. If it doesn't work for each of those sides, each of the combinations that you can make up, then it is not a triangle. So, for our examples here, we're checking to see if AB plus BC on this triangle over here on the right is going to be greater than AC. So, let's go through this look. We got AB, that's this side over here with 6. We got BC, which is 8. And AC, which is 10. Now, obviously, if you add 6 and 8, that's going to be giving you 14, which is greater than 10. So, this works for our theorem here. Now, are we finished? No, we're not. We got to go through and check out the other ones. So, let's check out our other ones. Now, for our next one, we got BC plus AC is greater than AB. So, this side plus this side has to be greater than this side. So, if this side is 6, and I add these 2, you can obviously see that these 2 are going to be greater than that. Now, let's check our last one. We're looking for the 2 sides that are going to be added together other than BC. So here's BC. The other ones we got are from A to C and from A to B. And if we add those together, we got 6 plus our 10, and that is greater than 8. So this triangle that we got here, this all makes a triangle according to this theorem. Now, occasionally they'll give you side lengths, and we're going to have to go through and run some math to check to see if it actually works. So make sure that you are aware of this as we go through. All right, first 1 theorem down. Let's go check out the other 3. All right, next one that we got is the side angle relationships in our triangles. So when we go through to look at a triangle, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. So if I look at my triangle over here, I see my longest side here is 10, my shortest side is 6. From this little bit of information here, B is going to be the largest angle because it is opposite our largest side. And C will be our smallest because it is opposite our smallest side. Okay? So this will go through and end up working out for all of our triangles. One of the things that you will notice, if you have two sides that are equal, that means that you will have two angles that will be equal. If you have all three of your sides are equal, then that means that all three of your angles will also be. Okay? Let's take a look at our next one, folks. We got the isosceles triangle theorem, and then we're going to look at this last one here. So, for the isosceles triangle theorem, it says the base angles of a isosceles triangle are congruent. So this is what I was just telling you about a few seconds ago. I got two sides here, AB and CB. These two sides are equal. And because these two sides are equal, they're going to be congruent. So these two congruent sides are going to be opposite two sides that are also, not two sides, two angles that will be congruent. Those ones will be the two base angles. Now that vertex angle isn't going to be comparable to these two. This is going to be a different size, but these two will be congruent. So that's going to mean that angle C will be congruent to angle B. Now, not only does this work in terms of going from the sides to the angles, this also works in reverse, meaning if we have our two base angles are congruent, C and A, that means that those two sides that are opposite of it will also be congruent, okay? So those relationships will go through and show you information as you go from one part of the triangle to the next part, one type of triangle to the next type. It'll just make sure that you are keeping your eyes open to see them. All right, next up, we got side angle relationships in triangles. So if two triangles have two sets of congruent sides, then the one with the larger included angle will have the longer side. So down here we got two triangles here. These have two sides that are congruent. This side here from A to B is congruent to this one with X to Y. Over here we got from B to C. That's congruent to this one over here from Y to Z. So in this case, even though we have two sets of congruent sides, we do not necessarily have the same exact triangle here. Only the sides are going to end up being equal. See over here, from X to Z, this one's larger than this one from A to C. Now, because this side is larger, that means that the angle that is formed here is going to end up being larger than this angle that is formed here. So the measure of angle Y is going to be greater than the measure of angle B. So if you go through and look at your different angles, you're going to be able to go through and verify and check some of these things. Now, what we're going to do real quick is we are going to do a quick bit of practice. Hello folks, coming back you with part 2. We're going to be doing some practice. So I'm going to be doing the we do it, and you guys are going to be coming down to do the I do it as well as the bottom. Remember, all these examples are based off of our notes, so there's nothing on this page that you should not be able to go through to do. So let's holler at some of these examples. Oops, sorry. Went back out for a second. All right, so first off in the we do it, it says state if the three side lengths can form a triangle or not. So if we're talking about forming a triangle in three side lengths, we're going to be using the triangle inequality theorem. So if you remember this means that we can add these two sides here, and it should be bigger than the side that we didn't add. Same thing with this and this. Same thing with this and this. When you add two of the sides up, it should be bigger than the third. So let's check. So for the first one we can do is 11 plus 5. That gives me 16, and 16 is greater than our other side, 5. But if we check the other two sides by adding 5 plus 5. This gives me 10, which is not bigger than 11. 11 is actually the larger of these two. So because of this, this first one is not going to work. So this first one is no. All right. Next time we got three sides. We got 4, 8, and 7. Remember, just like I did for the top one, we have to do these multiple times so we can make sure that this works for all of them. So I got, first off, 4 plus 8. Is this going to be greater than 7? Yes, it is, because 8's already greater than 7. And if you add 4 more to that, it would definitely be that way. So this one works out. Boom. Now, next one we got, we're going to do 4 plus 7. Now, is this greater than 8? Yes, it is, because 4 plus 7 gives you 11, which is greater than 8. So we're good again. And then lastly, we got 7 plus 8. And is that greater than 4? Absolutely, because both of those are already greater than 4. So if all three of those checked out, our answer for this will be yes. Make sure that you're checking all the sides here. The first one was a little easy because 2 of the sides matched up. So we just got to add it with the other one, and we only had 2 trials to do. The second one, we had 3 sets of trials that we had to go through to do. So we got to make sure that we go through and be able to get this next one in. All right, folks. Sorry, I just had to take a quick break for that last one. All right, so last one we got here. You're going to notice first off, we have 3 lengths like our previous ones, but our previous ones were all in the same unit here. We had feet, feet, feet. We had inches, inches, and inches. So this time we have 2 of the lengths in yards and 1 of them in feet. So the way that we deal with this, we got to go through and put either these 2 over here in terms of feet or this one in terms of yards, which is what I'm planning on doing. Now, if you remember back when we did unit conversions, 3 feet is actually going to be 1 yard. So all 3 of the sides for this shape are currently 1 yard. So that means that there's only going to be one thing that we got to check. Is 1 plus 1 greater than 1? Absolutely. So because of that, this works out for all the sides here. This answer is going to be yes. So A, that was a no for us because it did not work for all 3 of the sides. B, it was a yes because we checked it out and it worked out for all 3. And C ended up being yes because all 3 of the sides are equal and we were able to just work it out. All right. Now, here's what we got. We have here a triangle, and they are asking us to find the value of x in this triangle. Now, in order for us to find the value of x here, we have to keep in mind some of the symbols that they show us here. So, whenever they show us certain symbols like this one over here and this means that those 2 sides here are equal. Another thing that we notice is R2, oh, that's a little too big. Let's make that smaller. Smallen it up. All right. So if we see that on angles, they have the same little arc here. That means that those 2 angles are equal. Now, this is building up off of what we talked about after the triangle inequality theorem. And also with the hinge theorem down here. So the side lengths that we have should mirror the different types of angles that we have. So if 2 angles are equal, the sides that they are pointing to are also going to be equal for us, okay? So I know that these 2 angles here are both equal to each other, which means that this side and this side are also going to both be equal to each other. So what we do here, we got a nice easy equation here. 4x minus 8 equals negative 2x plus 13. All right, first thing that we got to do, we got to move our x's over to one side, our constants to the other side. So this 2x, I'm going to take and add it to the other side. So we got plus 2x. Those are going to cancel out. And then on this side, 4 and 2, that's going to give us a 6x. Now we got to deal with this 8 over here with the 6x. So instead of us having this minus 8, we got to do the opposite, which is adding. All right. So I add the 8 to the other side. This gives me 21 as an answer. So I have 6x equals 21. Now I got to get rid of the 6 over here by the x. That means I'm going to be dividing by 6. So over here on the left, I'm finally left with x by itself. This 21 divided by 6 is going to give me a decimal. This decimal is going to be 3.5. So that means that this is what x is equal to. All right. So folks, that was our we do it part. We did that together, which means that you now have to do the I do it part and follow along with some of the stuff that we've already talked about, okay? We know some of the things that we have, and we know what we should go through to try to figure out, okay? Now I'm going to let you know right now, this and this are going to be involving our isosceles triangle theorem over here. So I'm going to let you figure that part out. And down here, this is going to be involving our hinge theorem. And over here, this is going to be dealing with our side angle relationships. So good luck. Hopefully you are able to go through and do that, and we'll go over this in class. See you later.